G'day viewers. In this episode we're going to derive the maximum theoretical number of particle harmonics permissible within the electrogravimagnetic construct. The reason for doing this is to address the particle zoo problem within the standard model of particle physics. A key issue particle physics has is that a significant collection of particles have been experimentally observed. This collection has been described as a particle zoo. Quite frankly, if you take a look at the particle listing on the Particle Data Group website, you'll see that the so-called particle zoo is a complete mess. To make matters worse, the standard model of particle physics is incapable of explaining why so many particles exist or when their seemingly endless generation will stop. By utilising certain initial boundary conditions, we conjecture the maximum theoretical number of wave function energy states for all possible fundamental particles and all possible particular configurations. As you will see from our results, trillions of potential solutions exist. This means that the electrogravimagnetic construct provides a possible explanation for the particle zoo problem. However, it should be understood that the maximum theoretical number of particle harmonics may not denote stable particles. Rather, the vast majority of solutions may represent transitional energy states. We also show that trillions of wave function energy states may have existed or currently exist from the instant of the Big Bang to the present epoch. Once again, these potential solutions may help explain why contemporary particle physics is commonly described as a particle zoo. The way we derive the maximum theoretical number of particle harmonics and potentially resolve the particle zoo problem is by combining work from episode 8 with episode 9. Okay, that's enough chitty chat, let's get into it. In episode 8, we established a harmonic representation of fundamental particles. We demonstrated that fundamental particles can be arranged into a periodic table format based upon their harmonic relationship to each other via a reference particle. In fact, we demonstrated that the quantum vacuum cutoff frequency for most fundamental particles is given by an extremely simple equation, explicitly in terms of Compton frequencies, as appears on screen. The most important characteristic to note regarding our harmonic representation of fundamental particles is that the harmonic ratio is simply the ratio of two quantum vacuum frequency limits. We shall leverage off this characteristic going forward in order to derive the maximum theoretical number of particle harmonics, but for the moment we recommend reviewing episode 8. We will circle back to utilise the methodology from episode 8 a bit later on, but for now let's look at what we derived in episode 9. In episode 9, we ran the cosmological clock backwards, shrinking the size of the universe until it reached maximum permissible energy density. We described this size condition as being the primordial sphere. By running the cosmological clock backwards to the Big Bang, we established 4 key artifacts. These are: Number 1, the quantum vacuum may be described by a single frequency mode, as appears on screen, which is approximately 1/4 the Planck frequency. Number 2, the mass density of the universe at a moment prior to the Big Bang is given by the maximum permissible energy density as appears on screen. Number 3, the maximum permissible energy density condition within the electrogravimagnetic construct has been formulated independently of the classically derived Planck scale solution. Number 4, the classically derived Planck scale solution for maximum permissible mass density appears on screen. Please note that the electrogravimagnetic mass density solution is less than 0.9% of the classically derived Planck scale solution, or in other words, the classically derived Planck scale solution is approximately 116.5 times the value derived via the electrogravimagnetic construct. It is important to understand and appreciate that the classically derived Planck scale solution has no foundation in physical reality. Hence, no rational logic exists to bias the classical solution over the electrogravimagnetic solution. Our primordial sphere calculations are based upon the condition of maximum permissible mass density, which occurs at the Planck scale. However, since the Planck scale, as classically derived, does not include an experimental relationship function, it is non-physical. Please refer to episode 1 and episode 6 for more information regarding experimental relationship functions. To circumvent this impasse and to calculate a temporary experimental relationship function, we developed the primordial sphere methodology. This means that we are able to calculate the physical properties shown for a Planck-sized particle. However, because the universe was homogeneous at the Big Bang, the properties shown were everywhere. Okay, let's now tie episode 8 and 9 together. By combining methodologies from episode 8 and 9, we may determine the maximum number of theoretical particle harmonics relative to the quantum vacuum cutoff frequency associated with the primordial sphere. In other words, by utilizing the primordial sphere as an initial boundary condition, we may conjecture the maximum theoretical number of wave function energy states for all possible fundamental particles and all possible particulate configurations. As can be seen from our results, trillions of potential solutions exist. Thus, if we utilize the top quark as our reference particle, then approximately 3.7 trillion wave function energy states may have existed or currently exist from the instant of the Big Bang to the present epoch. Similarly, if we utilize the proton as our reference particle, then approximately 715 trillion wave function energy states may have existed or currently exist from the instant of the Big Bang to the present epoch. These potential solutions may help explain why contemporary particle physics is commonly described as a particle zoo. Moreover, it should be understood that the maximum theoretical number of particle harmonics may not denote stable particles. Rather, the vast majority of solutions may represent transitional energy states. In addition, we offer the following conjecture for your consideration. Number 1, the particle creation process obeyed the sequence indicated. Number 2, the particle creation sequence indicated occurred during the cosmological inflation period. Number 3, the Higgs boson is just another particle, that is, the so-called Higgs mechanism giving rise to all mass is a fictitious concept. Also, very importantly, no experimental evidence of the Higgs mechanism exists. Let's now summarize what we have learned. By inspection of the particle listings published by the Particle Data Group, the overwhelming number of experimentally identified particles is inexplicable and embarrassing for particle physicists. Consequently, the presently compiled database of particles has been described as a so-called particle zoo. This language is unsurprising, given the seemingly never-ending parade of new particles being identified via decay processes. Of course, these are not newly identified fundamental particles, but nevertheless, their existence provides circumstantial support for the electrogravimetric construct. The key lesson to be learned from this video presentation is that the electrogravimetric construct permits and potentially explains the vast array of experimentally observed particles published by the Particle Data Group.